Okay, now we just gone through the explanation, but I thought I would just kind of do some examples, questions, and the methodology that I'm going to be following. Now I'm not going to show you the example in the textbook because I actually think it's a bit of a letdown, because in the very last section they don't kind of fulfill it properly, and I actually think it's a bad example. So I am going to do question 1, which I think is pretty easy, question 8, and then question 13. I particularly want you to take notice of question 8 because I think that follows the example that they give to you at the front of the textbook. And these 3 style of questions are all different, but they all follow the same methodology, which I'm going to go through. Question 1 is quite easy. It's a parabola. Question 8 is, I believe, not quadratic. It's a cubic. And then question 13 includes limits and asymptotes. So here's the question 1, which I'm going to go through. Find the stationary points on the curve of fx equals x squared minus 3x minus 4 and determine its type. Okay, find the intercepts on the axis and sketch the curve. Okay, so this is the methodology we're going to be following because it's helpful to have a set procedure to follow. So step 1, we're going to find the first and second derivatives, so y dash and y double dash. In this case, it's going to be f dash x and f double dash x. The reason why it's good just to do these first is I like to have these at the top, and so I can refer to them quite easily. It also allows my brain to kind of focus on the question that I'm doing and not have to juggle too many things at once. So I just like doing these, and they're kind of set in stone at the top, and I can refer to them when I need to. Find the stationary point where y dash equals 0. That is telling me when the gradient is going to be 0, so that's going to be a stationary point. This is a little bit more to it than this sentence, just find these 3 words, is that you have to find those x values and then sub them back into the original function, which is this, and then find the y values. Okay, so we'll find out what number that generates. So there's actually 2 parts to this. You are not just finding the x value, you need to find the y value. So you need to put it in terms of points. Okay, this is a very loaded section. It does take a lot of time. Use the second derivative to determine their nature. Okay, so we're going to then refer to our f dash dash x and put in our x values from our stationary points. Then we're going to find point of inflection y dash dash equals 0. Also find the y value. So this is going to be a similar state of affairs as section 2 or step 2, where we find it and then we also have to find the y value of it by putting it into the original function. So a little bit of jumping around, going back and forth between y dash and y double dash. Determine the type of inflection, so that's what we're going to be doing, and x and y intercepts, and then graph the function. These are where x and y equals 0. Okay, and determine the type of inflection. I think that is if it's going to be the nature of it, if it's going up or down from left to right, or positive or negative. I'll have to get back to that. So let's do our first one, which is find the stationary points on the curve of this and determine its type and find the intercepts, axis, and sketch the curve. Okay, I'm just going to copy that. And this is question 1. So my fx equals x squared minus 3x minus 4. F dash x equals 2x minus 3. F dash dash x is going to be just 2. Okay, and I'm just going to put that in a box, and I can refer to it later. And is there any mistakes? No. Okay, so there's that done. Now I'm going to find my stationary points where this equals 0. Okay, so that's step 1. Just to be clear, step 2, f dash x equals 0. So we're going to 0 equals 2x minus 3. That's our point. We're going to plus 3 to this side. We can divide by 2. And I'm going to change that to a mixed numeral, which is 1 over 1 over 2 equals x. So there is an x value of that. I'm going to set it up nice and neat, so I'm going to keep going. Find the y value. Now, the reason I'm writing this out, and this is super annoying, is I like to try and do this habit. It's a very good habit of writing out what I'm doing. It's not for the purpose of you learning. It's actually for the purpose of keeping track of what I'm doing. So I know what I'm doing, my marker knows what I'm doing, and anyone who can pick up this piece of paper knows exactly what's happening. So it's kind of like little sections in a book, like subheadings. It's very, very good to try and do this. My tutor scolds me when I didn't do this. It's a really good habit. So I'm not just doing it for your purpose. I have had it drilled into me. Okay, the y value. So I'm putting it back into my original function. So this 1/2. So it's going to be f of 1 1/2. 1 and 1/2. So it's going to be 1 and 1/2 squared. I'll bring that up for you guys. Minus 3, 1 and 1/2 minus 4. Now put that in my calculator. Let's see if I can do this. I want to press shift. There we go. 1, and I'll put that in the brackets. 1 over 2 squared minus 3. Sorry. Shift. You can skip through this if you don't want to watch it. Okay, so I get minus 25 over 4, shift FD, I'm going to have minus 6 over 4. Just want to double check that. Yep, that's correct. Minus 6 over 1/4. Okay, so our point, bring that up for you guys because you can't see. Is going to be 1 and 1/2 minus 6, 1 and 1/4. Done. Okay, we found it. So that's step 2. Let's do step 3. Over the page. Okay, use the second derivative to determine their nature. Okay, we have our point, so let's determine the nature of that stationary point. Well, the thing is about this, the second derivative is just 2, as we established previously. Okay, so that means it's going to be concave up. Okay, so if, remember, f dash dash x is greater than 0, it's concave up, and it should therefore also be a minimum. Okay, it's going to be concave up. There's our stationary point. Well, it's going to be a minimum then. So the nature of this point is going to be, so we'll say that as 1 and 1/2 minus 6 and 1/4 is a minimum. Cool. Where are we now? 4. Find the point of inflection. Now I'm going to be honest with you guys. There is no point of inflection on this one. It is just a parabola. So I'm going to skip over part 4. Part 5, determine the nature of the inflection. Well, we haven't got inflection, so we can't find the nature of it. X and Y intercepts we can do, and then graph we can. So I'm actually skipping step 4 and 5 for this question because it's a simple question and it doesn't have these components, just to let you know. But we will be doing them later. So I'm going to skip right down to 6. X and Y intercepts. Now, this is when the X is going to equal 0 and the Y is going to equal 0, and we find for that. So our function, the original function was, this. And I'm going to find the y-intercept. Okay, so therefore x will equal 0. So, when the line is cutting the y-axis, x will equal 0. So let's put that in. Fx is going to equal 0 squared minus 3 times 0 minus 4. It's going to be minus 4. So that's our y-intercept. Our x-intercept is y equals 0. So that means this will equal 0. 0 equals x squared minus 3x minus 4. Okay, I have to factorize that. A number that times that, it's going to be x plus 1 and x minus 4. If you don't trust me on the maths, you can do that yourself. Therefore, x will equal negative 1 and positive 4. So our x-intercepts are going to be this. Sorry, our y-intercepts. Did I stuff that up? No, these are my x-intercepts. No, that's correct. So, let's graph this bad boy. Now, you should use a ruler for this, but I'm just sketching it real quick. Okay, here's going to be my minus 1. Here's going to be my 4. Here's going to be my, it's about there, minus 4, just here. And my point of inflection was 1/2 and minus 6.5. Okay, so let's say it's 4, let's say it's 1, so 1.5, it's going to be about here. And if that's 4 minus 6, that's 5 minus 6. Okay, just acknowledging that this is a little bit dodge. So, slightly bad example. It's going to be about here. So our parabola will look something, it will cut the 4, curve, hit that point, if I can, and go up through 4. Okay, a little bit pointy, but there's our answer. And just to compare what it looks like in the actual answers, well, it's a lot better than on this one because they scaled it better. That's what they get. Okay, so they've gone 2, 4, 6. Looks a bit neater, looks a little bit more curved, but essentially still the same thing. Sorry, mine should be more curved, but mathematically it's correct. That's an easy example. I'm going to keep referring back to this sheet where our next ones, our next two, sorry, and hopefully they can paint a clear picture of what you want.